Hi, it's Gadget UK here again. This time looking at something a little bit different. This is Harlequin. Now this is from one of my patrons actually. Something I offered to have a look at because it's something that interests me, and he was struggling. I gave him some hints and tips to help point him in the right direction, but he still couldn't resolve the problems he's got with this. So this is a ZX Spectrum clone, as you can see here. ZX Spectrum Super Foo, as it say, Harlequin Rev G or Rev 6, I'm not sure which. So you can see the ULA has been recreated with discrete logic here. So you know, you've got a couple of ROMs, Z80, is that a RAM? I think it is. Maybe a video encoder or something down here, I'm not sure what that is. We'll have a look in a minute. You've got your power regulation stuff here, you know, DC jack in. He said he was getting 5.6 or 5.7 volts on the TTL logic here, which is the big problem. That's probably killed something, I would think. So you can see, you know, switch mode IC here, you know, little switching regulator, crusty solder, not enough heat, that's the problem, not enough, well, it's heat's the problem. Get some decent flux on there and some heat and we'll reflow that. But in first inspection, he's done a good job. You know, if you look at the assembly of this, it's pretty good, it's pretty clean. You could do with a bit of a cleaning areas, there's a bit of flux still on there. But the solder points look okay, I think. It's probably assembled with lead-free solder, this. It's got that kind of appearance to it. I don't see any immediate cause for this not working. Even the soldering on that there, whilst it looks a little bit not perfect, let's say, I don't think that's the problem. It could be something as simple, well, I mean, the voltage side, we could have an issue. I need to deal with that first, I think, before we do anything. But then, beyond that, if one of these ICs is not faulty, it could be something like a resistor array installed the wrong way, or something like that, because obviously these are important. You've got pin 1, which is the common pin, and then the other pins have the resistors on them. It could be something like a diode the wrong way, or a transistor. Although, unless the wrong transistor is being used, or a faulty transistor, you can see, you know, the silhouette on the silk screen there indicates which way to install it, and everything looks okay on first pass. And it's the same with the orientation of all the ICs, I think. You know, the pin 1, you know, the little semicircle at the top is the same on all of these, which I would think is probably right. We'll have a look at the schematics and stuff for this in a minute, and there might be a photo of the board or something I can compare to. Could be something wrong with the ROM, maybe the ROM's got a corruption. From what he was saying is, I think when you power this up, you get like the white border and a black centre thing, as if like it's starting to boot. It doesn't complete its boot. So the next thing I would point out is look at the state of some of these spare chips here. They've come out of the things and just floated around, which is unfortunate, but we can, I think, hopefully salvage these just by carefully bending the pins back into position, straighten them. Yeah, one or two of those pins are super mangled. Can you see that? Look at this one here, it's pointing sideways. Do it little bits, don't do it one continuous movement, because the stress can actually break these off. Yeah, some more straightening is still required there. They're not perfect, but they're looking a bit better. Yeah, I'll spend some more time on that after. Anyway, let's just have a quick look. Yeah, so again, look, that one's pretty mangled there. It's a ROM, isn't it? And we've got a few TTL chips or something here, I'm not sure what that is, 7.4 something. Again, bent pins. That one's alright. Pretty mangled again, look. Oh, what a nightmare. How have they all come out of these? Yeah, you needed a bit of tape on the sides there, that's the problem. You might have assumed that they would have stayed in there, but they haven't. Let's just carefully stick those back into that tube actually. I've got a pin header and obviously another PCB here as well. That's really nice. So I've got a spare if we need to completely redo it. So I've got it set up on here. This isn't ideal, but you know what, it's just isolating it from the carpet. You want to wear an ESD wrist strap and work from an ESD benchmark, really. So if you look at the power area here, this is the first thing I'm bothered about. Is this outputting more than 5 volts, as the chap thought it was? Got a piece of sellotape stuck on my thumb there, can you see that? Anyway, so there are a few things here. We've got the DC jack coming in. a bridge rectifier. Now this is really nice because this means it doesn't really matter what you put in here to a degree. Because obviously, you know, you've got this here providing the 5 volts, but it's the fact you've got the bridge rectifier, you could put DC in and it will still pass through the bridge and the polarity will be flipped no matter which way around the polarity is. So that's really nice design there. You can't get the wrong power supply for this. Well, I mean, you stick 100 volts in there, you're going to blow it up. But, you know, any kind of like power supply like this is from Mega Drive, you know, it's going to output between 12 and 14 volts-ish. It's going to be fine. And it doesn't matter about the polarity because the bridge flips the polarity. So I mean, the things you want to check here before powering this up, we'll just check, A, we've not got a short on the supply, you know, the VCC to ground, but the inputs as well. Where's the bridge now? The bridge is here. So just on my diode test on my meter, let's just check that there are no shorts here. And there aren't. We should see the diode readings. I'm not sure why we're not seeing them at this stage. The positive is at the top here. Yeah, we're not seeing any shorts, and actually I think I'm seeing what I should expect to see there in terms of the diodes. The contacts are awful there. So we don't have a short on the input. So the next thing, let's just test on continuity again, and let's just check we've not got a short between ground. So on any of these TTL chips here, ground is going to be the furthest away from pin 1. This is pin 1, there's the semicircle there. Pin 1 is the first pin here, and VCC is the pin right at the top there. So we don't have a short. Let's just check on another one here. Yeah, so there's no shorts there. I have inspected the connectivity, and again, you could test on connectivity on your multimeter here just to make sure these are not short into each other. I'm not. So at this point, I think I am fairly comfortable. I don't see anything crazy with the board. I have inspected it versus the schematics and things. I don't see anything immediately wrong. So you know what, I'm going to go for broke, and we will plug in the Mega Drive power here. And if we just measure from the ground pin on one of these TTL ICs to the VCC pin, look at that, 4.96. It's got a nice healthy supply. So yeah, I think the concerns about this being above 5 volts were unfounded. That's not the issue. So the next thing we'll do is just connect up Composite video here. And as you can see, it's working. We're just getting a black screen. So yeah, this is the fiddly bit now, trying to diagnose exactly where the fault is. I'm going to get the logic probe out, I think, and maybe my little scope and probe a few different things. So we've got a reset pad here, can you see that? I'm just going to very carefully, while this is connected up, just short those two together and see what behaviour that has. None. Hang on, yeah, it reset that. I'll see if I can show you that. Sorry about the light glare there, it looks like the solar system overlaid over the screen. You see that? That was a short reset pulse, do another one. And again. So we're getting a reset. I'm not sure why we get that red screen there, but nevertheless it's resetting. So the next check here, unorthodox, just temperature testing with the backside of your fingers. And if we hover around, yeah, got some heat here. That one I think. Cold, 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 cold. Ooh, nice and warm. That one's toasty. Yeah, it's not enough to burn your finger, but that one's toasty. Cold, cold. So yeah, we've got a couple of ICs here that are a little bit warm actually, these two. So I'll inspect these, we'll take these out, might just probe these with logic probe as well, but we'll see if we've got any spares for these. So the interesting thing is, removing this one here that was getting warm, this was the warmest chip, it's just the same without it, as you can see here. So I don't know, that's kind of suggesting to me that maybe it has something to do with the fault. It might not do, could be a red herring. So I'll try and give you an update of where I'm at. I've spent literally the whole afternoon on this, actually about 4 hours. Incredible amount of time. There were lots of chips on here of the same type. So what I mean is, you've got like a 138 here, I've got an LS one there actually, I'll put the HCT one back in a minute. That was where I started because that chip was warm and it was marked HCT. It should have a HC chip, not HCT. So that was interesting, and it was interesting that was the first thing I landed on. Now, what you can do is you can take, there's like HC one down here, you can swap them around. see if the behaviour changes, and then there was another one of those 138s somewhere else, swap them around, see if the behaviour changes. So I tried that on every single chip on here, because we've got lots, you know, for most of the chips on here, there are multiple of them. So you can swap around just to see if the behaviour changes, and that is, you know, because they're in different parts of the circuit, you would expect to see a difference in behaviour, and I saw no change. Where I've got equivalents or replacements, I've swapped those chips as well, just to rule them out. I've gone through everything. As you look at this diagram here, see these red dots? This means that I have a high level of confidence that the chips themselves are not the actual issue. Well, there's a side note actually, I'll come back to in a minute, but they're not faulty, is what I'm trying to get at. I even swapped out the Z80. The ROM chip is where I ended up last. You'd think I might have started there, but I ended there last. I dumped the chip that was on here, reprogrammed it. It wasn't working. I had to change this jumper to the other position here, which is interesting. Now it's behaving the same as it was previously. So I'm not sure how that ROM was originally programmed. I've got a dump of it. The Atmel 27C or 27C512s or the L5256s, the ones that came with it that were all pins all mangled, I've dumped those and checked them. They're all the same. It's identical copies of the same ROM, but not the ROM that was on here and not the ROM that's on there now. So that's confused me in its own right. We'll perhaps retest those later when this is hopefully working. But coming back to that side note I was on about, some of the chips on here, many of them in fact, are marked LS, the 74 LS type. They're supposed to be HC. I think that is probably the issue, because I'll be honest, I can't find anything wrong with this. I've checked the resistor arrays, I've checked all these transistors in the various places, I've inspected the solder points here, I've had each of these chips out as I've tested, you know, with replacements in each position and stuff, or swapping them around. I can't see anything wrong with this board. Well, the Spectrum is officially doing my head in. Can you see what's going on here? This was from probing with the logic probe, one of the data pins. It suddenly started loading or saving, I'm not sure which. This is just absolutely crazy. You can see I've got no data source connected to this, so I can only assume it's saving something, trying to save. It's crazy, this. Now, I've swapped out the LS chips with HC chips, still just the same. I tried a Diagnostics ROM, can't get that booting on this. It's had all of the chips replaced now, it's had different Z80, it's had different RAM. I think the only thing I haven't ruled out are these three chips here. And that is still an LS, that 174. So maybe that's the answer, I've ordered one of those. But I can't explain what's going on. Let me try and cycle the power and see if I can get it to repeat what it's doing. I tell you what would be really strange if it loaded something. That would just freak me out completely. Yeah, I don't understand. Anyway, let's just cycle the power. So you can see that's the behaviour. And if I just probe the third data pin in the bottom right, see, look, just from probing it, acts strange. Now if I cycle the power while it's doing that, and this might be a clue, just see if it does the same thing again. I doubt it. No, it's doing some sort of weird reboot loop thing, look. Take it off. Let's try the second data bit. Let's try that. Yeah, it's doing strange things when I probe the second data bit as well, look there. I've actually got a flashing cursor, which makes me think maybe it's operational, but it's a display thing. I don't know, it's very strange. So every one of the little transistors there that are next to the keyboard connector were round the wrong way. Pin 1 is the emitter. The emitter was on the collector pin, you know, so it's flipped around in orientation. So I've removed them all, just tested it without them, it's just the same, but I figure these might need to be there in order to get it to boot. But I mean, that's another problem. Not only do we have HC chips in place of LS chips, we've got these transistors around the wrong way. So we're making some progress there. What you just saw there was the menu, I think. The test, and this is as it warms up, it goes around here, those blocks. Those were not appearing when it was cold, so that's interesting. It's almost like something is having to warm up somewhere before we get to even this point here. That, I think, is a message, some sort of indication of a fault. There should be some text there, I think. So, yeah, whatever's wrong with this, something to do with the text output side of things. You know, it can't seem to output any graphics. It's like coloured blocks and that's it. That's all it seems to be capable of generating. I'll just cycle the power again. You can see when it first powers on, you get that. I think that might be normal. Again, it might have some text there. And then it goes into some sort of test here, and you get the coloured patterns here as it, you know, and the coloured blocks as it goes through the RAM in a minute. Yeah, so that's all normal. But that's only when it warms up, and it's still not right. So we've dealt with a few issues. We had LS chips swap for HC chips now, transistors around the wrong way. We are getting a boot, and this is with the Diagnostics run, by the way. Cut a step out here. I've spent literally hours upon hours looking at this. I had the logic probe on earlier. There's nothing really much to show you, because what I don't want to do is get bogged down with a pin out of every single chip and go around every single chip, because then I will spend an incredible amount of time. Now, I could do a logic analyzer capture, but you know what? I don't know very much. There you go, there's the menu. I recognise these coloured bands here. That is correct. And this bit in the middle should be menu options and a bit of text at the bottom and the top there. But yeah, if I did a logic analyzer capture, I don't know the first thing about the Z80, really. I'd have to start looking up opcodes and trying to work out what on earth is going on. I don't understand the memory map of the ZX Spectrum. Obviously, if I was super keen on doing it, I could spend a number of hours, dozens of hours, a week or two, of all of my spare time working through this, but I'm not that interested in understanding how the Z80 works. I've got enough stuff going around in my head to do with the 6502. I seriously don't have any more space up there for the Z80 as well. So where do we go from here? Well, I'm still waiting for the 74HC174. There's a chance it's related to that. It's possible. But we could also have a fault on one of the other chips there that I don't have a HC equivalent for. So, I'm not sure. I might end up ordering a kit of this myself, just so I've got a full set of spares so I can work out where the fault is here. So there's a quick look at the keyboard. It's got a nice clicky feel there. I quite like that keyboard, it's nice. Not like the original membrane ones, these have got little tactile switches below them, I think. If I just scope that chip there, can you see? This voltage here is not accurate. You can see that for the reflection. It says 1.47, so you can get the screen a bit closer there. But if you look at the peaks and troughs there of the pulses and the voltage, you know, what it's saying 1.54, it's not. But nevertheless, that's what it's showing there. And it's the same if I look at the other pins around a chip that I think is good. Again, looks almost 1.6 volts. It's not going to be 1.6, it's going to be nearer 2.5 volts, I think, somewhere around that region. If we look at the HC32 over here, sorry, not 32, it's 138, isn't it? Look how low this voltage level is here. It's saying that you can see that 20 millivolts. It's like it's automatic. It's moved the scale to scale it up. So whilst the voltage there is not right, that just shows me that that level is very, very low. This chip is not right. Now I've swapped it. It behaves slightly differently, but the problem is not solved. So I'm going to have a look at the schematics to see where this is wired to in case something around it is causing a problem. Whoa, it's working, as you can see. I'll show you what I did to work this out. It was that 138 that was not right, actually. But you know, I concluded swapping the LS chips for HC chips. It was just the same. And I thought this has got to be another case of a mistaken component somewhere, because everything looks okay on the board. We swapped the transistors, and you can see the keyboard. Keyboard works there, I'll show you in a minute. But the keyboard works, you know, that would have been the next issue. But that keyboard connecting to the address lines and the transistors being the wrong way around basically would have caused some interesting problems as well, probably, with the address lines. So we dealt with that before it became a problem, certainly from the keyboard aspect. But as I say, it could have been interfering with the address lines because those transistors were the wrong way around. So annoyingly, I lost a clip, so I've had to re-record this bit. The 138 that we homed in on right at the start there, when it was a little bit warm, ultimately, that's what was wrong. After scoping some of the pins around here and seeing the voltage level being super low, combined with the fact that this was warm, I thought there must be something going on here. So I looked at the schematics to look at the wider area. And notice that this should not be a HC138, it should be a HC166. I think data, is it shift register? I can't quite remember now. So this passes the sprite data. Having the 138 in there meant that data for all 8 bits of the sprite were not coming across, which is why there were no graphics. But ultimately these transistors were causing a problem as well. I think they were interfering with the address lines. They were certainly causing it to read ghost keyboard inputs, if you see what I mean, you know, fake keyboard presses that weren't there. That's why it was saving. It was these here, you know, randomly you were getting keys being detected as being pressed as a result of those being the wrong way around. So the next thing I'm going to do, I'm going to get some flux on here and reflow this, just to make the points look a little bit cleaner there, because can you see they're not particularly tidy. We'll do the same thing over here. We'll tidy up these and tidy up the tab on the regulator here. It looks looking a bit blobby, that, get some flux on there, reflow that. The other thing I'm going to do, can you see this connector here? Look, it's a bit wobbly, it's floaty. I'm going to use the desolder station, remove it, and then put it back on so it's flush like this one here. Can you see that one's flush with the board? There's no, you can't wobble it. The thing with this, it's going to wobble and the pins are going to break, so it does need to be flush. I think everything else on here is okay. He's done a very good job on this. It's clean and tidy. So we'll just get a bit of chip quick flux there. I swear by this stuff, it's the best kind of flux for this kind of job, really. I will need to obviously toothbrush that area because I can't clean that up very well with cotton swabs. And we'll just get a little bit down this side as well. It's quite hard to distribute actually when it's like this. You're better off getting that chip on first before you stick the caps and the crystal and everything else around there afterwards. Get in there like that and just dab in and out. Occasionally I'm dabbing the iron into the my copper wick thing there, you know, just to get any extra solder off, because we don't need tons and tons of solder. Could, in theory, just try a bit of dragging along here. But as you can see, you can join them up if you're not careful. So I'll do the same thing with this, just get a bit of flux on both sides. This might be the hard bit because it's going to absorb a ton of heat when we do this side, certainly. And again, there isn't much clearance here, so we'll just try and heat these and just see what happens, really. So the final thing I need to do here is just remove that keyboard socket. I'll show you the other bits that I've just cleaned up in a minute. They're not great, but you know, the better. The interesting thing with this, can you see they're at different heights? It's like it looks fine actually from one side, but just one or two of these look like they've been pulled or something. I don't really know. I don't know. And the pins here were really all malformed. So anyway, they've been straightened out now. And there's a bit here melted off. You can't quite see it because it's going dark, just on the edge there. So I've straightened that up. So I think we just need to just carefully get that back on now. I can see why they've been bent, because unless you move the resistor pack over like that, they will get in the way. I mean, technically it doesn't matter which way around you put this, so one way is going to be easier to fit it than the other. So just finishing up here, sorry about the light bloom on the left. This is obviously, I've not been doing anything with this for, I don't know, about 3 weeks now. So I thought I'd just test it again with the test ROM. You've seen that's working, so what I'll do next is I'll stick the standard BIOS in, and hopefully it should then boot to the Sinclair prompt. And then we'll try and connect up the Div IDE. I'll connect the keyboard up as well, and we'll just make sure it's working, test a few games. So yeah, we're testing on a box at the moment, and the box is on top of an Archimedes, which is on top of an Archimedes. It's like a stacked load of systems underneath this, so I've got hair on my hand there. So if we just get this ROM in, I've reprogrammed this ROM with a decent version of Sinclair Basic, so let's just give that a try. Oh yes. So we'll connect the keyboard up and I'll plug in the Div IDE. So it's a while since I used this Div IDE 2K14 here. One thing I would say, I did a review on this and I was very impressed with it at the time. On reflection, there's something that's could be better on this. And that is the jumpers here, this bottom block used to switch between whether it's compatible with a +3 or a +2 I think, or plus 2B, or a 48K or a grey Spectrum, the grey plus 2 or whatever. And you've got to get these jumpers right. If you get them wrong, you can kill it. And it doesn't tell you what they are on here. I mean, there's a thing here that says EEPROM ROM2 OE, but that means nothing to man the beast kind of thing. You really need something printed on here. It would have been better if that had not been on here, and it would have explained exactly what these switches are for here in terms of the different modes or something. Maybe, I don't know, a sticker stuck on here. I might just do that, print something off and stick it on here, because you know what, at some point I'm going to fall a cropper and this is going to end up dying. I could do with a new one of these. I might get one of the ones from the Future's 8-bit or something like that, I don't know, because these things, whilst the early ones like this have got dip switches, now they're automatic. You can just plug them in and it'll work no matter what. And we'll carefully plug it back in again. Pressing the key. Right, so disconnect the power. Now let's get the keyboard up. It seems to be at least booting. Now it's really nice, this keyboard. I do like it. I'm not sure where he got it from. Let's just have a look on the underside here. Yeah, there's no markings or anything to indicate where it came from. It does say the Ginger Electronic, so maybe that's where it is. 48K KDLX 1.3. But yeah, it's very nice, that. I do like that. So then we're going to make sure the connections are straight and push it straight in. This is easier said than done. I think that's in. So we've got power connected. It says press the key. Let's press space. Ah, that's worked. So if we press the NMI button on the Divide E, oh yeah, that's interesting. I'm sure I pressed it twice then. That was really weird. I'm not sure if there's some sort of incompatibility there. Anyway, right, so I've now got to try and work out how you go up and down this list with a 48K keyboard. I'm guessing you can use the arrow keys, so I presume you've got to press Shift and then down. Yeah, there we go. Shift and up. So let's go into games. Return, presumably, enter. Yeah, there we go. So sorry about the extreme angle there, but as you can see, that is working. The Goonies has loaded. Press 1. In fact, that's the demo. Look, the demo's working alright. I'll just let it go around the demo. Now, there's no speaker connected to this, but you know what? I'm going to assume that everything else is okay with this, because I've checked everything. I can't really see anything else wrong with it. I will load a few more games and show you those, just to show you they are working. You can see the awful drift on the chroma, composite. The composite signal's awful there, dot crawl. But it is working. There we go, so on Kempston joystick, let's hit play. So I've got the joystick connected to the Div IDE 2K14. Can't remember how you play this now, is it forward? Yeah, forward, there we go. And you've got two gears, haven't you? Low, high, let's go. To high. If I back down to, how do you get to low? Oh, I don't know. Maybe it's automatic. Anyway, that is working. I'm not sure you're supposed to tell which colour flags are which actually on this. Yeah, I'm not sure whether that's indicating an incompatibility here, because you can see the colours of the flags at the top. And this just could be the way the Spectrum version is. How are you supposed to know which colour flag is which, because they're all blooming black? Let's drive a little bit further and see if we see any others. Look, yeah, it's just a flag. Hit the rocks again. Oh, this version's painfully slow. So here we go, we'll select Manic Miner. And yeah, I think that's working. Return. Now, I don't think joystick does work. I was going to say I didn't think joystick worked, but it seems to be default to Kempston here, and that has worked. Up. I'm so useless at this game. It's up. So many years since I played it. I didn't realise the collision detection was so close there. Oh, why am I jumping straight into that? Let's try that again. I don't remember it being this hard. Right, let's just wait till he's going the other way and follow him. Yeah, you jump quite high, don't you? That's the thing, so you've got to jump earlier. Yeah, I would say it's working. So I think I'm just going to clean it all up and package it up. Yeah, I didn't jump early enough there, did I? Package it all up, ready to go back. I'll show you the A500 that he's also had sent to me so that he can save on shipping coming back. But you know, all the way to, is it Australia or New Zealand? I think it might be New Zealand. It's going to be super blooming expensive, and I think they're going to have to be packaged separately. So before I clean this up and send it back, the other thing I'll do is just test out the other ROM chips he sent. The one thing I would say, and you know what, he's capable of doing this himself, I'm sure. If he's got a solder sucker, I'll assume he'll have a solder sucker just to desolder pump. And I would replace that socket just because, you know, prior to it getting to me, he's probably had ROMs in and out, in and out, in and out. And it's not a very great socket. So the other thing we'll do here is just test his other ROM chips. This one is not erasable correctly. It doesn't blank. So one of them is faulty, but it's got a couple of OTP chips here, Winbond ones, that have got something programmed on there. And I think it's just 48K basic, so we'll test that. Yep, that boots, so that's one. Now if you remember right at the start of the video, these are totally mangled pins. So I'm amazed that first one went in okay. Let's try the second one. We'll left line it first. Push it in, there we go, it's in. Switch it on. Yeah, that one's not working. So, try switching the EEPROM pin. Let's try that. Because he might have that configured a certain way. No, he's not. That one does not work. Yeah, so I switched back to the original ROM. So one of his mass ROMs works, the other one doesn't, and he's got an EEPROM that won't erase properly. So I'll just disconnect the power, and we'll carefully disconnect this keyboard here. So just carefully pull it out. So can you see? Oh, the same thing's happening there, look. When they go in, they're not going in straight. Hopefully you can see that. They are bending to the sides. So, you know, when he connects this up, he's going to have to be super careful with it, because ultimately these will break off, and then you'll have to, you know, strip some of this back a bit. I can't help but wonder if a better connector here would be some sort of ZIF type socket or something, I don't know. You know, a zero insertion force. I don't know what you could get that's in the right size there. Yeah, I've been thinking about this. I think if I was building one of these myself, do you know what I would put here instead of this? This is good if you're going to use a proper keyboard with a ribbon, you know, instead of wires like this, because the ribbon will fit nicely into there. But for you know, an aftermarket keyboard like this, you'd be better off putting a strip of turn pin holes there, I think. Now, it might be a bit fiddly to get those in, but if you get them totally straight, those would push quite nicely into a strip of turn pin, I think, and make a relatively good connection. Trying to get them in there is very difficult, because you've got to go straight down, you know, at 90 degrees. They've got to be perfectly straight, and you've got to try and hope for the best and push it in. But 9 times out of 10, they'll bend slightly one way or the other. You'll tend to find it works, but if you just move the keyboard a bit, it stops working. So when he assembles this inside a case, it could be quite fiddly, trying to get the keyboard just right. You could just desolder those, pull them off, and put a strip of turn pin there. That's what I would suggest if he's struggling with that. Or pull that sticker off and stick on a label here. There we go, 48K basic. So he did say if once I could keep this spare board that came with it, so I might have a go at building this myself. Yeah, that's really nice of him. The other thing he's included is choke here, but that's obviously too big. Or maybe it's not. I think that would fit this board actually. Yeah, that would fit on here. I'm pretty sure that would fit this board. I'm not sure why he went with the smaller one. You might have felt it was a bit too close in terms of, yeah, it is. Can you see that's pretty tight? It's right up to the edge there, and right up to the edge over there, but you know what, I can fit that in there. So the keyboard was originally taped onto here, so I think I'll just do the same thing. We'll just bottom align it, and then just use a little bit of sellotape here. So I've kept one of the regulators he sent here. He might have intended me to keep all of those, I don't know, but I'm not going to use them all, so I've just kept one for that board. And then he had a piece of sponge here. I'll add some bubble wrap, I'll stick that under there just to help support that, I think. And then he's got his diagrams and things here. I've got PDFs of these if anybody wants them, and scans of them as well, just in case, including the parts sheet there. He's got some instruction things here, more schematics and things. And here's a final look at the board. So you can see the soldering I did there was okay on those transistors. They were all the wrong way around. I did resolder the two, well, one I think of the keyboard connectors, or was it both? I can't remember, because they were both kind of floating off the board, and ultimately they would have broken off. So in summary, we replaced, I don't know, about 15 or so of these chips, quite a few. They were LS instead of HC. So it's looking pretty tidy now. The other thing I did for the eagle-eyed, I don't know if I mentioned it earlier, there was a wire here instead of a jumper. So I removed the wire and fitted a jumper and put a jumper header on there for him. So I think it was the NTSC PAL these used to toggle between NTSC and PAL. We tidied up the connections there. You know what? It's not massively better than it was because the caps and things around here make it very difficult. That's the first thing you should put on the board before you do anything else on these. Do the surface mount stuff first. I'll give it a final test before I stick it back in. You can see the soldering here. Yeah, it's a bit better. You know, you can see, but I ended up with like a little bit of a wedge. You know, you need a lot of heat. So if I'd got the new soldering iron that you've not seen yet from Dermot Sweeney onto it, it would have been a bit easier. But with my 15-watt iron, that was proving pretty difficult. I ended up using the desolder station as well in order to try and tidy that up. But you know what? It's better than it was. And the connections here are a lot better than they were as well, but they're not perfect. So yeah, I think overall that board is really good. He's done a good job. I'd be interested to know whether he sourced the chips individually himself or whether it came as a kit, because whoever sent them, you know, with LS versions, LS variants, that's incorrect. So the jumper up here used to toggle between, I think, a mask ROM and an EEPROM because the pin out is subtly different. So yeah, that's the position that's in. It's in the bottom position there. I think the one down here disables or enables the speaker. You've got your speaker contacts there. So I've inspected both sides of the board anyway. I see no remaining issues, so yeah, it's ready to go back. I'll find something to stick that in, an ESD bag or something, and then I'll stick some bubble wrap on top. So just the final test before I package this up. You can see it's working. The video output, it's not that great. It's the same as probably a proper 48K Spectrum, perhaps a bit worse. My 48K Spectrum looks better than that, with an original, you know, proper ULA. It's certainly amazing to see the ULA exploded into all this CMOS logic here in this way. Dave Curran, I think, is doing a video on this soon in terms of reverse engineering it. Not really reverse engineering because it's been reverse engineered, but looking at the schematics and stuff for this and explaining how it works. It's really interesting that we ended up focused on the chip that I started on, actually. You know, this was the only chip that was getting warm on the board, and in there was a 138, and ultimately I think it needed to be, was it a 166, I think it was? I can't remember, I'll correct it up top left if I'm wrong. Yeah, and that was what was feeding the sprites data. You know, this is why we had no sprites. It seemed to be, well, once I swapped all the LS chips for HC chips, it seemed to be booting, but we had no graphics, and that was what the issue was. But these were all the wrong way around as well, and these sockets were kind of floating. Go on then, let's test the sound. You can hear the speaker I've got connected, it's super loud. Good grief, that's piercing my ears. To be fair, it's not the right impedance speaker, but sound is working. Yep, that's ear-piercingly working. And that's the speaker I was using. It's unmarked in terms of its impedance. We can just measure the resistance across here. Just let me go and get my multimeter. So just measuring across that speaker there, you can see it's 7 point something ohms, so I'm guessing 8 ohms. So I'd like to give a special thanks to Conrad for sending this all the way from New Zealand. It's been a joy to work on this. I did spend quite a crazy amount of time to start with, swapping chips and swapping the LS ones for HC ones and stuff, trying to rule out where the problem might be. But that's always one of the difficulties when you try and take over looking at a board that someone's assembled themselves. You don't know what's wrong. You know, you've got to look at every single component and see if things are, you know, mounted correctly and the right components in the right positions. It's just unfortunate that Conrad didn't notice that this should have been a 166, and it might be that he's been misinformed, because looking at the diagram he provided, it did say 138 there. That's another reason why it took me a while to spot it, because I was comparing his diagram with you know, handwritten chips in each of the positions on that diagram, and this did indicate, the diagram did indicate a 138 should be here. So I'll package that up and get that back off to Conrad in New Zealand. Thank you very much for watching. If you can support the channel, please visit my Patreon page. Consider donating $1 a month. It just means we can continue to do more videos. Thank you very much, and I'll catch you in the next video.